Alright, in this video we are going to be covering another topic of O-level ad maths, and this is called circular measure, as you can see. And this time also I've done exactly what I have been doing for the past couple of videos, that I've highlighted a couple of key concepts, not a couple, but yeah, half a dozen I think, or a handful of key concepts. And I have tried to sort of highlight those concepts and how, because they're frequently tested concepts, so I've tried to highlight those concepts in past papers also, in past paper questions also. If you happen for watching the last couple of videos, you know exactly what I'm talking about. So just so that let's just go over the key concepts quickly. So you have the arc length. You'll be asked to find the arc length. Okay, circular measure, as you know, is just a study of circles and sectors. Okay, and then in that you sometimes have triangles and quadrilaterals that you deal with. And then you have area of sector, angle at O, and then I have further divided area into three more categories. You'll be asked to find the area of segment, area of triangle, area of shaded region, and then perimeter, perimeter of sector, perimeter of segment, and perimeter of shaded region. Now in this particular PDF, I have compiled all the important stuff, the formulas, and I have made these different cases where you'll be asked to find the area of segment and the area of shaded region. And I am by no means suggesting that this is all you need to know about circular measure, but what I'm saying is that if you do, when I went over the past paper questions, these are the key and the frequently tested concepts that I found. So I just sort of compiled them and gave you guys formulas and stuff with the help of which you can work out when you come across questions like these. So if you have a figure like this, I've written the formula how to calculate the area of segment and how to calculate the perimeter of segment. And then here also, if you have a shape like this, I've written exactly what you need to do in order to find the perimeter and area. And then just like that, you have a couple more cases. And a couple of other things: how to convert from degrees to radian, sine rule, cosine rule, and also how to convert from radian to degrees, which I just realized I haven't written, so I'll just do that real quick. So all you gotta do is you gotta multiply it by 180 upon pi in order to convert any value from radian to degree. So theta radian to degree. Yeah. And then a couple of important circle properties to remember: angle properties or circle properties, whatever you want to call it. So I've compiled that also. And then you have a couple of examples and solved questions from my online classes that I take. So I've compiled that over here also. So download this PDF. I'll leave a link to it in the description, as I have been in the past couple of videos, and make good use of it. And if you do all of that, inshallah, you'll be fine. So what I'm going to do in this video is that I'm going to be solving some past paper questions for you guys. So as I mentioned earlier, that I have highlighted the key concepts, and this is, as you can see, colored in red. So let me just open it up real quick, that what exactly this is suggesting. So this is basically dealing with arc. This is basically dealing with arc length. Okay, now let's see what it says. Sorry, it's not dealing with arc length. It is dealing with angular too. I just realized I've colored it. I've given it the wrong color. So I'll just fix that real quick. So yeah, there you go. Anyway, so this question is from October-November 2019, paper 1, variant 2. And I do have a very similar, in fact, I have the exact same case above in these notes, where I've written what exactly you need to do if you have to find the area of the segment. Okay, you can see over here. So if you apply this in that particular question, you'll get the answer and you'll get it right, inshallah. Okay, so one thing I should also mention is that don't have a head-on approach with questions, with circular measure questions. Sometimes questions are going to be very simple, that you have to find the arc length. So you can just use the formula for arc length and work it out. Sometimes you have to find the area of sector, again use the formula, work it out. But sometimes when you have to find the area of shaded region, or sometimes you're given the shaded region and with the help of that you need to find out some other value, in those questions it is always recommended that you first write down the key values, write down all the formulas that you will have to use, and then work it out. Work backwards, basically, sort of like reverse engineering. Anyway, before starting off questions like these, it's always recommended, in fact not recommended, you must convert your calculator into radian. By default it's in degree mode, so convert it into radian, because whatever angles that we have in this question in circular measure are in radian. And if you don't do that, you will get all these questions wrong. And once you've done that, once you're done with these questions, you're doing some other questions, so make sure to turn it back, or just give it a or just reset your calculator, so to bring it back into default setting mode. Anyway, so as I mentioned, this is a question from October-November 2019, paper 1, variant 2. Let's see what it says, and let's see what we are given, and what exactly we need to work out. So it says here the diagram shows a circle, center O, radius 10 centimeter. The points A, B, and C lie on the circumference of the circle such that AB is equals to PC. So we're sort of dealing with an isosceles triangle. Show that angle AOB is equals to 2.24 radian. Okay, so AOB is not exactly drawn. So I'll use a different color so you can distinguish. So AOB. So the question is basically talking about this. I need to show that angle AOB is equal to 2.24 radian. My calculator is in radian mode, so again, don't forget to do that. Correct to 2 decimal places. Okay, now since OB is the radius, that means OA will also be the radius, since it's a line that's starting from the center and going all the way to the circumference. So any line that I draw for that matter will be equal to 10 because it will be equal to the radius. Okay, now AOB is this angle, all right? So what do I have? I have two sides. In fact, I have all three sides and I need to work out one angle. Now, the way to do that is cosine rule. I've written cosine rule in this PDF also, so make sure to revise that. I'm sure you've done it in math also. So, sine rule, cosine rule, area of triangle, all those concepts are still very relevant for circular measure. So here's what I'm doing. Angle cos AOB, in fact, cos of AOB is equal to 10 squared plus 10 squared minus 18 squared. Remember to always subtract the square of length that's opposite the angle that you're working out, divided by 2 times 10 times 10. So let's see what we have. So let's work it out, in fact. So 10 squared plus 10 squared minus 18 squared divided by 2 times 10 times 10, and then we do cos inverse of the answer. So I'm looking at AOB is equal to, I should write what I've gotten here, cos inverse of 31 upon 50, minus 31 upon 50 in fact. So I'm looking at AOB is equal to 2.239, which means if I round it off correct to 2 decimal places, I get 2.24 radians. So that's that, 3 marks in the bag. Then it says find the perimeter of the shaded region. So we're looking at, this is basically a segment that has been shaded and we need to find its perimeter. Okay, so again I have mentioned what you need to do when you're given a shaded region like this and you're asked to find the perimeter. So if you want to find the perimeter, here's what you will have to do. Let's first identify the lengths that we have to add. Okay, again, do not have a head-on approach. First identify whatever it is that you want, whatever it is that's given, and then gradually work your way towards it. So here's one length that I need to add. So I'll write it over here that the perimeter of the shaded region is basically going to be equal to AC plus the arc length AC. So there are two lengths that I need to add. Okay, and that's sorted out. Once I've sorted that out, only then will I move on and see what is it that I have to do in order to get my hands on these lengths. Okay, now let me switch to a different color. So if I make a if I connect O and C, and the purpose behind doing so is that you can see that OAC is basically a sector and AC is the arc length of a sector that has center O. Okay, so I'll further highlight what I'm talking about. So this is what I'm talking about, to be precise. Okay, now don't forget that this length is going to be 10 because this is also the radius. Okay, and we just worked out angle AOB to be equal to 2.24 radian. And if you look at triangle AOB and you look at triangle COB, so you can see that these two are same triangles. Okay, you have 10, 10 and 18, and the other triangle also has the same lengths, 10, 10 and 18. So that means this angle angle COB will also be 2.24. Okay, there's no need to work it out again. These are basically congruent triangles. That's the word that I was looking for. So therefore the angle between the two radii will be the same. Oh, and however, that does not necessarily mean that angle AOC will also be equal to 2.24, because angle ABC is not an equilateral triangle. It is an isosceles triangle, but it's not an equilateral triangle. We know for sure that CB and AB is equal to 18, but what AC is equal to, that's something we don't know. It may be equal to 18, but we don't know that for sure, so we're not going to make any false assumptions. Okay, what we can do, however, is we can very easily work it out. We know that the sum of all these three angles will be equal to 360 degrees because it's a circle. So all I got to do is if I want to work out angle AOC, so I'll write it over here, that angle AOC is basically equal to 2 pi, because that's what 360 is in radian mode, minus 2.24 plus 2.24. Okay, so let's see, what do we have? So we're looking at 2 pi minus 2 times, so I'm using the last answer that I got, so I'm using the answer key here. So I'm looking at AOC to be equal to 1.80 radian. Okay, so now I'm very close to what I want. I have the angle between AO and OC, and that is equal to 1.80. So I'll write it over here, 1.80. Now there are two things I need to work out. I need to work out this length that I'm now highlighting in green. Okay, I need to work out AC, and I can work out AC using cosine rule, and I need to work out arc length AC, and we have a formula for that. I've written it in this PDF. It's S equals to R theta. Anyway, so I'll work out AC first. There's no particular order that you need to follow. You can work out whatever length you want first. So I'll work out AC. So in order to work out AC, I'll have to use cosine rule. So here's what I'll have to do. The radius is 10, so I'll do 10 squared plus 10 squared minus 2 times 10 times 10 times cos of 1.80. And remember, this is AC squared. I've got to write a square. So let's work it out. Here's what I'm doing. 10 squared plus 10 squared minus 2 times 10 times 10 cos of answer. Okay, the answer is still in my calculator. And then once you do get the answer, do not forget to take the square root of it, because this is AC squared. So AC is equals to 15.6665. So I'll just write 15.666, although it just continues forever. But I'm using more decimal places because it's not the final answer. Once we have the final answer, which is the perimeter, then we'll round it off. So we have AC, so I'll put a check mark there. Now let's focus on finding out the arc length. So I'll write down the formula for calculating the arc length. It's equal to, S is equals to R theta. And you can see that we've already worked out theta, that's 1.80, and the radius is given to us, was given to us at the very beginning, it's 10. So we can very conveniently work out what arc AC is going to be equal to. So it's simply going to be equal to 10 times 1.80. So AC will be equal to, don't need a calculator for this, it's just going to be 18.0 centimeter. And then I already have the length of AC, so in it I'm just going to add 18 to get the final answer. So I'm looking at 33.666. So the final answer, I'll write it over here what I've done. So I've done 15.66 plus 18.0. So the perimeter is equals to 33.7 centimeter, which is the final and the correct answer. So I hope you've understood this question. Now let's move on and do another. Oh wait, there's another part to it, I just realized. So this part is the area of shaded region, which is why I have highlighted it green. So we're talking about area of shaded region. So this shouldn't be a problem. I'll take a screenshot of this so we don't have to do a lot of back and forth, and put it next to the question, so just to make it easy for you guys. Okay, there you go. So theoretically, area of shaded region will be equal to sector, because that's the larger shape, sector AOC minus triangle AOC. Okay, now we have all the ingredients to work out the area of the shaded region. One thing, however, that I should point out is that the angle that we have, 1.80, now so far I was using the answer key in my calculator, so I wasn't worried about rounding it off. But this time, since that's not what I have in my calculator anymore, so we're going to go back and we're going to find out the value of AOC. Maybe not correct to 2 decimal places, but maybe correct to 3 decimal places, just so that we don't end up using the rounded off value, because if your answer is not accurate enough, then that's something you can be penalized for. So this value, which we later off rounded off to 1.80, was basically 1.804, and that's exactly the value that I'm going to be using when I'm working out the area of sector and the area of triangle. Now, area of sector, the formula for which the formula for calculating area of sector is half r squared theta. That I've given it above in the PDF. So half times 10 squared times theta, which is 1.804, minus area of triangle, the formula for which is half times AB sine C, formula that we have been using in O levels also, except this time the angle is going to be in radians. So let's work it out. So 0.5 or half, whatever you want to write it as, times 10 squared times 1.804. So we're looking at 90.2 minus 0.5 times 10 times 10 times sine of 1.804. So we are looking at 48.64. But again, I'm going to be, so this is not 48.64, and it has a couple more decimal places. So I'm going to use the answer key in my calculator. So I'm doing 90.2 minus answer, and I'm looking at 41.55, which will then be rounded off to 41.6 centimeters squared. And that is the final answer, and it is also the correct answer. You do have a small margin of error. It's accepting between 41.6 or 41.5. So as long as it's within that, you're good to go. If it's not, then remember, do not use the rounded off value. Always have the pre-rounded off value, just so that if you need it for later parts, you have that available and you can use it to work out the following parts. Anyway, so I hope you guys have understood this question. Let's move on and do another question. Now we come to another question, and this is question number 7, and this I should mention is from May June 2020, paper 1, variant 1. All right, let's get straight to it. So it says the diagram shows an isosceles triangle OAB, all right, and OA is equals to OB, angle AOB is equals to theta radians. The points C and D lie on OA and OB respectively. So make sure that you're looking at the figure also while you're reading the question. CD is an arc of length 9.6 centimeter of the circle, center O, radius 12 centimeter. The arc CD touches the line AB at the point M. Okay, so basically we have a sector and we have a triangle. As far as the sector is concerned, we're given the radius. As far as the triangle is concerned, we're not given anything at all. We're given part of the length, but nothing other than that. And we have to find the value. We are told, however, that the arc CD touches the line AB at the point M, and we have to find the value of theta. Okay, now we're given the arc length 9.6, and arc length, as we know, as we should know, is equals to r times theta. So 9.6 is equals to 12 times theta. That means theta will simply be 9.6 divided by 12, which is equals to 4.5 or 0.8 radians. We get 1 mark for that, and this was a pretty simple part. Let's do part B. Now part B says find the total area of the shaded regions. This was kind of expected. It's quite predictable that if you have a shaded region, you will either be asked to find the area or the perimeter of it, or perhaps both. I think we have to find both. Yeah, we'll have to find both. And a shape like this, I've mentioned in these notes that what exactly you need to do in order to find the area or the perimeter of when you have a shaded region that looks like this. So let's first analyze what we have here, what we're dealing with, and then we'll see how we can work out the total area. So we have a triangle, which is the larger shape, and we have a sector, which is a smaller shape. So that means theoretically, if I want the area of shaded region, all I got to do is I got to take the area of triangle AOB, and from it, I just need to subtract the area of sector COD. Yeah. And if I do that, if I do it right, I should have my hands on the area of the shaded region. Okay. Now let's see whether we have all that we need in order to work out the area of triangle and the area of sector. So as far as area of triangle goes, we can either use half times space times height, or we can use half times AB times sine theta. Now the problem with that is, even though we have theta, we don't have OA or OB. Okay, we have what the length is from O to C, but we don't have CA or OA. So we'll have to think outside the box here. So what happens if I draw a line from O to M? Now remember, this is a line that originates from the center of the circle and goes to the circumference. That means this is basically going to be the radius, and it's going to be 12. And we just worked out theta. That means this is going to be 0.8 divided by 2, and this will also be 0.8 divided by 2, because what we're dealing with now, as far as OAM is concerned and OMB is concerned, we're dealing with, since it's an isosceles triangle, sorry, so that means if I draw a perpendicular, okay, OM is a perpendicular line, this will basically divide the angle into 2, okay, and bear in mind that this will be a 90-degree angle, and there's another reason why this will be 90. AB is sort of like tangent, and OM is your radius, so radius and tangent meet at 90 degrees. This is a property that I've mentioned in these notes because it's relevant to circular measure. So this is 0.8, that's sorted out. Now if somehow I can get my hands on this length, which is the hypotenuse, okay, I will be able to find out the area of the shaded region, area of triangle, and then ultimately the area of shaded region. So the length that I'm looking for is the hypotenuse length. The length that I have is the adjacent length. So what trigonometric ratio can I use? I can use cos, and remember that your calculator must be in radian mode. So cos of 0.4 is equals to adjacent, which is 12. upon hypotenuse, which is basically the length from O to A. So that means OA is going to be equal to 12 divided by cos of 0.4. So we're looking at 13.028, and again, I'm not going to round it off prematurely. I'll leave it as 13.028. So if this is 13.028, this length here, this length, yeah. So this length that you see, folks, is 13.028, which means that this length also will be 13.028. So you can see where we're going with this. We have now what we need in order to work out the area of triangle. So I'll switch to blue. Yeah, I already have. So as far as area of triangle AOB is concerned, it's going to be half times 13.028 times 13.028 times sine of 0.4. No, 0.4, sorry, 0.8, because we're taking the entire triangle at once. Okay, so that's that. Let's work it out. So 0.5 times answer. So I'm going to be using the answer key so that I don't, like I said, end up rounding off prematurely. 0.8. So I have the area of triangle AOB. This is equal to 60.882 centimeter square. Now I need to work out the area of sector COD. So I'll switch to a different color for that. I'll switch to red. So oops, sector. Okay, as far as area of sector goes, it's a no-brainer. It's half r squared theta. You have the radius, that's 12. You have this, you have the entire angle, and that's 0.8. Now I noticed that I've written 0.8 here, but as I was supposed to write 0.4. But anyway, 0.4 is 0.4. So area of sector is equals to half times 12 squared times 0.8. So let's work it out. 0.5 into 12 into 12 into 0.8. So I'm looking at 57.6. Now all I got to do is take 60.882 and from it subtract the answer. So now I'm looking at area of the shaded region, which is equal to 3.282, and I'll leave it at 3.28 so that it's correct to three significant figures, and that's the final and the correct answer. Then it says find the total perimeter of the shaded region. So again, do not have a head-on approach for this. I'm just going to clear all this mess that I've made here. I'm going to take a nice screenshot of this, put it next to the question so I can show you guys what I'm doing simultaneously. Let me copy this. Okay, now, as far as the perimeter goes, that means I need this length that you see here. In fact, I'm going to highlight it because I think that'll look better. This length, length AB, and the length CD. So all in all, what I'll need is, I'll need AC, and I can just times it by 2 because that's what DB will be equal to. And then in it, I need to plus AB and then arc CD. Now some of these lengths I have, some of them I don't. So as far as arc length is concerned, that I have. AB is something I don't have, I'll have to work it out. And AC is also something I almost have, but I still need to work it out. So I'm going to work out what AC and what DB are going to be equal to, or I'll just write BD so it's the same order. So notice that we worked this out to be 13.028, and we know that the O to C is 12. So all I got to do is, I'm going to do 13.028 minus 12. So 13.028 minus 12, so I'm looking at 1.028. So that means 2 times 1.028. Now I need to find out what AB is. Now AB is basically the third length of the triangle, and since I have the two other lengths and I also have the included angle, so I can use cosine rule to work it out, and that's exactly what I plan to do. So for now I'll just leave it as AB, and then as far as arc length is concerned, that's 9.6. that was given to us at the very beginning. So now I'm focused on AB. So AB can be worked out by taking 13.028 squared plus 13.028 squared. This will be the square of AB, by the way, since we're using cosine rule. And then we'll do minus 2 times 13.028 times 13.028 times cos of 0.8. So be very careful when you're working this out in your calculator because there are a lot of decimals that you're dealing with. So 13.028 squared plus 13.028 squared minus 2 times 13.028 times 13.028 cos of 0.8. And then don't forget to take the square root of it. So you're looking at AB, which is equal to 10.146. Now it's time to find the total perimeter, basically to sum it up. So perimeter is going to be equal to 2 times 1.028 plus AB, which we now have, it's 10.146, plus the arc length, which is 9.6. So let's work it out. Plus 9.6 plus 2 times of 1.028. And let's see what we get. So we're looking at perimeter is equals to 21.8 centimeter, which is the final and the correct answer. Anyway, so I hope you've understood this question also. And now let's move on and do perhaps one more question before we call it a day. So here's the third and the final question that I'm going to solve in this video. You guys can let me know if you want me to solve more questions, or you can send me specific questions of circular measure that you want me to solve. And this is from May, June 2020, paper 2, variant 2, the paper that got cancelled due to COVID-19. Anyway, so it says two circles with centers C1 and C2 have equal radii of length r centimeter. The line C1 and C2 is a radius of both the circles because it runs from the center of circle 1 to the center of circle 2. And then it says the two circles intersect at A and B. All right, we can see that. It says, given that the perimeter of the shaded region is 4 pi centimeter, find the value of r. Okay, now, I've picked this question because it's a slightly tricky question. We're not used to dealing with questions like these. So considering that the two circles are of equal length, are of equal radii, and C1 and C2 is also the radius of both the circles because they're both the same, what we should do is, and what we can do is, we can connect for C1 to A and C2 to A also, and the same C1 to B and to A also. Okay, now how does this help? Here's how this helps. So the two triangles that we're dealing with, the red triangles that you see, are basically going to be equilateral triangles. Okay, now this is not an assumption, this is something we know for a fact. So C1 and C2 is equal to R, okay, and C1 and A will also be equal to R, and C1 and B will also be equal to R, and C2 and B will also be equal to R, and C2 and A will also be equal to R. So all these lengths are the same, so that means we're looking at two equilateral triangles. Now, if we're looking at two equilateral triangles, that means, what does that mean? That means that they'll have the same angle. If they have the same angle, so the sum of interior angles of a triangle is pi, or 180. It's 180, which is basically then converted into pi radian. So all I got to do is I got to take pi and divide by 3. So I'm looking at pi upon 3. So that means this angle, let me just zoom in a little. So this angle is going to be pi by 3, and not just this angle, all the other angles in fact, which means that this angle will also be pi by 3. Now how does this help? So if you focus over here, you will notice that we're sort of looking at a sector with center C and arc length AB. Okay, that's what we're looking at. And exactly the same thing happens on the other side also. So we're looking at another sector with center C and arc length AB. Okay, one is basically AC2B, and the other goes from A to C1 and then B, and they're both going to be equal. Okay, because we're looking at two equal circles, a circle with equal radii, and we're looking at equilateral triangles also. So if I can somehow work out the arc length that goes from A to C2 to B, and the formula for working out the arc length is basically S is equals to R theta. Now, radius is something we don't know, but we do know that theta, if you sum it up, is going to be pi upon 3 plus pi upon 3, so that's 2 pi upon 3. So that means we're looking at R times 2 upon 3 pi. So this will be equal to 2 upon 3 pi r. And since both the arc lengths are equal, so all I got to do is I got to multiply it by 2. And now I have the perimeter of the shaded region, which is going to be equal to 4 upon 3 pi r, which according to the question, not according to me, but according to the question, is equals to 4 pi. So that means all I got to do is, since this right here, I should mention, is the perimeter of shaded region. So perimeter of shaded region, according to the question, is equal to 4 pi. So I just need to equate the two. The 2 pi's get cancelled out, and 4 also get cancelled out, and I'm looking at r is equals to 3 centimeter, and there you go. That's how we've worked out the value of r. Then it says find the exact area of the shaded region. Okay, so I'm going to clear this up, and let's see how we can find out the exact area of the shaded region. Okay, so what I would like to do is, I'd like to divide this shaded region by 2. Okay, And why have I done that? Let me explain. So the reason why I've done that is because if I can work out the area of half of the shaded region, all I got to do is I got to multiply it by 2. So if I can somehow get my hands on this, then all I got to do is, like I mentioned, I just need to multiply it by 2 and I'll have the area of the entire shaded region. Now, do I have all the ingredients that I need in order to work out the area of this shaded region? The answer to that is yes, now I do. Considering that I have the radius is 3 and this length will also be 3 and this angle that you're looking at will be 2 upon 3 pi. Okay. Now theoretically, area of the shaded region is going to be equal to area of the sector minus area of the triangle. So again, what I'll do is I'll just quickly take a screenshot of this, copy, and I'll paste it over here. Whoopsie. Okay. Yeah. So here's what I'm doing. I'm first finding out the area of the region that I'm highlighting in blue for you, and I'll switch to blue for that so you guys know what I'm doing. So since this is a sector, area of sector is equal to half times r squared, so that means times 3 squared, times theta, so that's going to be 2 upon 3 pi. And by the way, since it says exact, that means I'm going to leave my answer in terms of pi only. So this 2 and this 2 gets cancelled out. 3 squared is 9, 9 upon 3 is 9 upon 3 is 3, so we're looking at 3 pi. Now 3 pi is just the area of the part that I've highlighted in blue for you. Now from it, I need to subtract this region, the region that I'm highlighting in green for you. So I'll switch to green for that. And since this is a triangle, I can very conveniently use the formula half times a times b times sine c, and c here will be 2 pi upon 3. So let's work it out. 0.5 times 3 times 3 times sine. Make sure that your calculator is in radian mode. 2 pi upon 3, close the bracket. So we're looking at 9 under root 3 upon 4. Now, in order to find out the area of the shaded region, which is something that I've already colored in red, all I got to do is I got to take, so I'll write shaded region. Now remember, we've only worked out half the area of the shaded region. So 2 times 3 pi minus 9 under root 3 upon 4, which will then be equal to 6 pi minus 9 times 2 is 18, and then 18 divided by 4 is 9 upon 2, so 9 upon 2 under root 3. And this right here is our final answer, and it's also the correct answer. And with this, this brings me to the end of this video. I hope you guys have understood it, and lastly, I would strongly suggest that you try out a few questions on your own. You will notice a repetitive pattern, and once you get a hang of those key concepts, then inshallah you'll be fine and you can do whatever question it is that's thrown at you. Anyway, so that's all for this video. I'll see you guys in the next one. Until then, take care.